Hello and welcome to In the Lab. I'm Mr. Walker and we're going to be looking at electricity, specifically electric circuits. Now here is my guest presenter.
Good morning, good afternoon, and whenever you're watching this. Hi, my name is Bradley. I do science and I'm really good with electrics.
Oh, well, we'll see if he's really good with electrics today, won't we? Because we're going to be using our circuits. Now, my helpful helper is going to pass me a full tray of electric circuits to show you what you might use in lesson at King's Leadership Academy, Warrington. We have got a full set of circuits, or full set of components, and as you can see it says connecting leads, because normally there's a bunch of leads in there as well. So this is what we're going to be using, Bradley. We're going to make some circuits and we're going to see if you can tell me what each of the components does before it does it. One, two, three batteries. Each of the batteries has a voltage of 1.5 amps. Now, what is voltage? Do you know, Bradley? Can you tell me?
The power of the electric going through the wire.
You could look at it like that. The voltage is the potential difference between one point and another. In other words, how much voltage, how much power in a sense, although power is a slightly different thing, how much there is in our circuit. And if we've got 1.5 volts in this battery, we've got 1.5 here and we've got 1.5 here, how many volts in total? What's the potential difference between the start and the end of our batteries?
Well, you start off by 1.5 and then you should get 4.5 after all the three batteries.
You've got it because you add them together. Each battery gives us 1.5. So we've got 4.5 volts. That's not a huge amount of volts. In your home, you might have something like 240 volts going through most of your appliances. That's quite a lot, especially with the current going through as well. Now, what's current, Bradley? What's that?
Like the flow of the movement of the electric in the wires.
There.
But
Yeah,
it's like
there.
flowing.
And what is moving in the wires? You nearly said it. The movement of the
electricity going through the wires.
Yeah, the electrons or electricity. That's what electricity is, the movement of electrons. So the voltage means we have got more, and the current means we've got more flow. So if you've got a high current, it's pushing it round with a much faster flow, basically. You could look at it like that. Resistance is resistance to the flow. So if there's something that has resistance in a circuit, it stops the flow of electrons, or it reduces the flow of electrons. So I get what you're saying. It's trying to drain its power, or a better way to say it is it's trying to power the circuit. It's trying to move the electrons round. And if it can't, because something is in that circuit, there's resistance. Now, everything has resistance, even wires. Things will struggle to flow through wires, but there's only a small amount of resistance. So we're going to look at what we can put in that circuit to either help the flow, or use the flow, or even restrict or resist the flow. So let's have a look at that. We've got our three batteries in a row, and you might notice they've got to be lined up the right way. If they are lined up differently, so we turned one of them round, for example, it's not going to work. They've all got to be lined up in the right direction so that electricity can flow.
Wait, I have a question.
Yes, go for it. Question.
Why is that one black but the red one's plugged into it?
It doesn't actually matter. A lot of people think that it's really important to only use red wires or black wires, or we must have red and black. It doesn't actually make any difference. It's the same wire, it's the same material, it's just a different outer coating in case you wanted to highlight certain things. We just have lots of red and black, so it really doesn't matter. So in your lessons, any wire will do. As long as the electricity can flow, that's the key thing. Now, how do we know electricity is flowing? We're going to put a light bulb into there. So if I stick one of these connecting leads in there, and Bradley, you can do the other one, we can see that we have got electricity flowing around the circuit and it's lighting up the bulb. Now, what else can we do? We could put a switch into the circuit. Bradley, what is going to happen?
Basically, as soon as you touch the switch, like flick
the switch, yeah.
It's basically going to be like a light bulb where it instantly turns back on.
Oh, the light bulb is going to turn back on. Well, let me plug in the switch and we'll see what happens. You've noticed you had to flick the switch. It's even showing you here, because there's a wire between these two terminals. It's showing that in the up position, the circuit is broken. There has to be a continuous, complete circuit for electricity to flow. And if we go down, that closes, we get a complete circuit and electricity can flow. You're doing really well so far. Let's put something else into it. I'm going to use a 10R resistor. Now we mentioned resistance earlier on. So what happens if I unplug this, I put that in there, and my helper's going to hand me another wire? It's coming, it's coming. Any wire will do. He's having a think, isn't he? That's it, that's the one, thank you very much. What happens if I plug this in and I complete the circuit?
It won't, the light bulb won't turn on because of how much resistance that has.
Oh, let's have a look, let's see if you're right. 10R, by the way, means 10 ohms. It's another way of writing that. So 10R is a 10 ohms resistor. So that means there's 10 ohms, that's how we measure it, of resistance added to the circuit. Here we go. Nothing. You were right. You were absolutely right that there's so much resistance here, it completely stops the flow of electricity.
But isn't it true if there's more batteries, that would at least have a little glow on it due to the resistance?
You've got it. If we increase the voltage, then we might have enough potential difference to make the flow happen, to make the current, to make the circuit flow in electricity, and yes, we'd have to have a high resistor. So if I put in the 100R resistor, it's not going to make any difference. We've already stopped all of the flow of electricity. So 10 stops it, 100 would definitely stop it. We would need loads of batteries to overcome a 100 resistor, and we'd need a few to overcome a 10 one. So we have looked at lots of different components, but there are many more to come. That was just part 1 of basic circuits. We'll do the rest in part 2. Bye for now.
Bye. Remember to like and subscribe for more varied scientific content.
Like and subscribe to In the Lab. Come on, don't be heartless.
Like and subscribe.